Firstly, a fan motor is configured to run at 30 Hz, using a variable speed drive. This is considered to be a very lightly loaded motor, and consequently quite inefficient. The PowersStar Max system is switched on. By accessing the onboard HMI, we are able to control and see exactly what's happening with regard to electrical parameters. The raw supply voltage comes into the building at 240 volts, 20 volts above the recommended voltage for CE marked electrical equipment. Once the PowersStar Max system is switched on, it automatically steps down the voltage in steady increments to a preset voltage, in this case 220 volts. The first step change occurs immediately and is a 10-volt reduction. After 30 seconds, the Max system automatically drops the voltage by another 2.5 volts. This process of stepping down by 2.5 volts continues until the set point voltage is reached. When tap 5 is reached, equating to a 20-volt reduction, the Max system will continually measure and adjust the voltage to its optimal level, ensuring that the highest efficiency and energy savings are achieved without putting the load at risk. The process of tap changing can be viewed at the lower half of the screen, shown by the green LEDs on the printed circuit board. Tap 1, 229 volts, 0.58 kilowatts. Tap 2, 228 volts, 0.57 kilowatts. Tap 3, 225 volts, 0.56 kilowatts. Tap 4, 222 volts, 0.55 kilowatts. Tap 5, 220 volts, 0.54 kilowatts. The PowersStar Max is switched off, and the fan motor is then set to run at 40 Hz via the VSD controller. This is a more efficient setting for the motor, and we should see slightly reduced savings. The PowersStar Max is once again switched on and configured via the HMI, which can be automated or done remotely. The same step-down process occurs, with the electronics attempting to find the optimal tap for maximum savings. Tap 1, 229 volts, 0.66 kilowatts. Tap 2, 227 volts, 0.64 kilowatts. Tap 3, 224 volts, 0.64 kilowatts. Tap 4, 222 volts, 0.63 kilowatts. Tap 5, 220 volts, 0.63 kilowatts. The PowersStar Max is taken out of circuit again, and the fan motor is finally set to run at 50 Hz, which is the optimal frequency for this particular fan to run at. The PowersStar Max is switched on, initiating the step-down process once again. Tap 1, 229 volts, 0.78 kilowatts. Tap 2, 227 volts, 0.77 kilowatts. Tap 3, 225 volts, 0.76 kilowatts. Tap 4, 222 volts, 0.76 kilowatts. Tap 5, 220 volts, 0.75 kilowatts. Although the savings from running the motor at 50 Hz have reduced, we are still seeing 8.1% overall kilowatt-hour savings using PowersStar Max. This is due to the induced negative power created from the step-down transformation, which reduces the consumption of the load, irrespective of the type of load being used.